The following program is brought to you by Caltech.
So good evening and welcome. My name is Tom Prince. I'm a professor of physics here at Caltech, and I'm the director of the Keck Institute for Space Studies. Very first, I'd like to actually make a few thank yous here. So we are the Keck Institute for Space Studies, and I definitely want to recognize and thank the W.M. Keck Foundation of Southern California, which many of you know, for their very generous support of our institute. They support all of our programs, including the program that you're at tonight. We are also, in this particular event, partnering with the Planetary Society, who is co-sponsoring this event. Last but not least, I'd like to thank the staff of the Keck Institute for Space Studies and all the staff here at the Caltech staff for actually organizing and putting on this event. So a couple of things. One of, I don't know how many people here know what the Keck Institute for Space Studies is, but we are, you can think of us as a think tank for future space mission studies. What we do is we initiate programs. We bring together groups of approximately 24 scientists and engineers to brainstorm new ideas, new concepts for the future of space exploration. Early in 2011, a very special thing happened. The Keck Institute was approached with a new proposal from a group of engineers and scientists, and it actually sounded like a rather crazy idea. And the idea was send a robotic spacecraft out to an asteroid, a small one, grab it, actually more true to form, actually bag it, put it in a bag, drag it back to the orbit of the moon, and then have astronauts visit it with the new launch vehicle and crew vehicle which are being developed at this time. So rather crazy idea, but at the same time, what we did is we said, that's worth trying. And so we accepted that particular proposal, and we formed a group of scientists, engineers, propulsion experts, some astronauts who are here tonight, representatives from industry, orbital dynamicists, brought that group together in September of 2011, and they then started on the initial feasibility study for what we call the asteroid return mission. So that was 4 days of work for them. They came back in February of 2012 for 2 more days, and then they wrote a report in May of 2012. So why am I giving you these dates? An amazing thing happened then. In March of 2013, just 10 months after that group of roughly 24 people wrote their report, NASA fully embraced the asteroid return mission. It had never been on their agenda before. They put it in their budget, and they made it a significant component of their future human spaceflight plans. To my knowledge, this is totally unprecedented, that a small group of roughly 24 people does some brainstorming, spends roughly about a week looking at this and studying it, and then writing up a report. Probably the report took more than a week. And then less than a year later, NASA adopts it as a major part of the space program. So one thing is that we have numerous people from that original study here. I'd like the people who were involved in those, one or both of those original 2 workshops to stand at this point. Okay, so these are people who have So if we as humans ever grab a small asteroid and bring it back to the orbit of the moon, you can say you saw the people that thought that up. Okay, so what are we doing this week? We have roughly 36 people back to brainstorm. Now, assuming that we have such an asteroid return mission, what can you do with it beyond that single mission? Can you use it for further exploration of the solar system? Can you utilize the resources of asteroids, for instance, to make further exploration? So tonight we're going to hear about a discussion about the future of human spaceflight. Our moderator for tonight's discussion is Dr. Louis Friedman. He's Director Emeritus of the Planetary Society, so that's very appropriate. But also he was one of the 3 initial co-leads that put together that proposal for that original study for the asteroid return mission. So without any further, Lou is going to introduce the panel for tonight and tonight's topic.
Well, thanks, Tom. I'm gratified by that very nice introduction. I really very much appreciate it. It is a remarkable group of people, and as I commented to certain NASA officials when we first heard that they had made that mission, this was the fastest transition from not invented here to we own it that I've ever experienced in the space program. It is exciting. It's an interesting idea. It's not a completely understood idea, and that's part of the whole effort to go into it in depth. NASA's studying it in depth now. JPL is studying it in depth. Several NASA centers are involved, and we'll just see how that mission makes it forward. But every step of the way, it seems to have gotten better. So we have a lot of people here from thinking about this future of human spaceflight, and I wanted to get together with the Planetary Society and the Keck Institute for Space Studies, and I thank them both too, to discuss this important question. Because the human spaceflight, whatever you say about it, it's NASA's image. It's what NASA stands for in so much of the public mind. And you get so many misrepresentations about it. I've given many public talks in which I talk about humans to Mars, and maybe a third of the audience thinks humans have been to Mars. Another small percentage of the audience thinks Martians have come here. You get misinterpreted. You hear about many people, a certain segment of the population thinks that humans have never been off the planet. They never went to the moon. And you probably read, there's a lot of misunderstandings about it, including one misunderstanding is that NASA's gotten out of the human spaceflight business, which is just not true. There's a lot of activity in the human spaceflight business. It's reaching a new era, an era which we hope takes us out of low Earth orbit and into the solar system. And so I thought it was very appropriate to take advantage of the fact that we have astronauts participating in this workshop that we're holding for a couple of days to bring them together and discuss the future of human spaceflight. And then you can draw your own conclusions as to what that future is. We are fortunate to have three veterans of human spaceflight, people who they are human and they have done spaceflight. And they represent three eras of great exploration. I think it's also significant is, you think of astronauts, they just got in the vehicle and they went up and they went someplace, and I'll say a little more about that. But all three of these guys have gone out of the spacecraft and done extravehicular activity, which I think is a great accomplishment. And so they are true veterans of the space program, and they're not just about the past of human spaceflight. They're all involved in the present and, I hope, the future of human spaceflight. So I'm going to introduce the three speakers now, and then I'm going to let them take over the program. And at the end of the program, we'll form ourselves into a panel and take some discussion both among them and with the audience. Our first speaker will be Rusty Schweickart. Rusty was an Apollo astronaut, went on the Apollo 9 mission, and I almost need to say no more. I mean, if a guy's been an Apollo astronaut, that's enough of an introduction, right? But he's had an incredibly varied and active career in many activities. He's been an executive in private industry. He's been the Commissioner of Energy for the state of California in the first Governor Brown administration. He played an crucial role in Antarctic safety evaluation as part of a National Science Foundation panel. He was the backup commander of Skylab and came up with and led the whole emergency activity to save Skylab when its sunshade broke. He's a founder of the Association for Space Explorers, which is the group in the world that consists of all the people who have flown in space. And he's also a founder of the B612 Foundation, which has been a leader in conceiving how to deal with the issue of planetary defense. asteroids, which we love, certainly all of us who have been working on the subject love them dearly, but they are a threat too. And if one of them really turns out to be a real threat, we won't love them anymore so much. But Rusty has been a leader, not just in thinking about how to deal with them, but technically, but also politically. He's been very active getting United Nations consideration of some of the international issues involved with asteroid mitigation, hazardous asteroid mitigation. So as I say, he's had a very varied career in all of these activities, remains active in this, and he'll bring a perspective from all of these fields, I think, to our talk. Our second speaker will be Dr. Thomas Jones. Tom is a planetary scientist, so close to those of us who love planetary exploration and planetary science. He's specialized in asteroids as part of his thesis work and his research activities, but he then became a shuttle astronaut and was part of the shuttle program. He's a well-known author as well, written several books, including Skywalking, which is one of the most highly rated books of personal experiences in space, and remains active as a planetary scientist, as an author, as a participant in many programs evaluating the future of human space exploration. Our third speaker is also a shuttle astronaut. Garrett Reisman is at SpaceX, the company that's doing the commercial launch vehicle development of the Falcon, and I'm sure we'll hear about that. He is the person at SpaceX who's responsible for the development of the crew vehicle and the use of the crew vehicle, and as you know, and I'm sure we'll hear, that they want to break new ground in being the first company to actually develop a commercial crew vehicle and have this as a service to the government instead of a government-supplied activity. Garrett, as I mentioned, is a shuttle pilot, and he, of course, remains very active, and in fact, is getting prepared, I think, for a launch in the very near future, in another week or so. So, not of him, but of his vehicle. Or is it of you? Maybe, I don't know. Anyway, those will be our three speakers, and as I mentioned, I'm really honored to be able to be on the program with them and pleased to participate. And with that, I'm going to turn it over to them and let the evening proceed. Thank you.
Good evening, all. Appreciate the introduction, Lou. We're going to address this subject of where we're headed from here. I'm going to open it up by setting a bit of background, which is, at my age, my specialty, as opposed to foreground or future. I'm going to leave that to the experts, Tom and Garrett. But I thought I'd provide a bit of context, and in particular, I wanted to talk about two things. By the way, to give you an idea, I'm sure that over half of the audience wasn't here yet when I flew. My 45th flight anniversary was last month, a little less than a month ago. So, I mean, that gives you an idea of how far things have gone. So I'll leave the future work to Tom and Garrett, who are really experts and are not only much more familiar with the current planning and thinking for future spaceflight, but actively involved in it, in fact, and so they can speak firsthand to it. I'm really an observer and read the same things you do. But I wanted to address two things. One was the kind of major shift in human space exploration that occurred about 5 to 6 years ago. And that was, of course, the transition from the Bush administration to the Obama administration. And there was a major turn that took place at that point. And it was not just the sort of standard turmoil from one administration and especially one party to the other, but there was a major shift in the way we're thinking about space exploration. And then the second thing I wanted to do was just to give a bit of an introduction before these guys start talking about it into deep space. Deep space is different from what we've been doing, and I wanted to try to illustrate that. So this transition, to pick that up, this transition occurred, as I said, at the turn of the administration from Bush to Obama. At that time, without going into a lot of detail or going back into all the arguments and debates and that kind of thing, the fundamental facts were that the Constellation program, which had existed in the Bush administration, was in some serious trouble, delays, overcost, and that kind of thing, and was sort of sucking all of the oxygen out of the environment that had previously been a pretty broad and comprehensive NASA. And so President Obama called for a review of the U.S. space program. And to do that, he set up an independent commission called the Augustine Commission. I won't go into a lot of the details. But the time in which all this occurred was a major shaper of what has happened since. And in particular, I want to take you back to 2008 period and remind you of a number of things like Lehman Brothers collapse and credit default swaps and bursting bubbles and mortgage-backed securities, world collapse of the financial system, et cetera, TARP, et cetera. When you think about that, that president had a few things on his plate of higher priority than the National Space Program. And so they were a little slow getting out of the blocks and getting the review started. The review took longer, of course, than it was planned. And by the time the results and recommendations came out of that process, which was itself quite controversial, we were into the next election cycle, well into the next election cycle. Well, now the result of that timing coincidence, because of the great financial crisis demand for attention, the result of that was that, and I'll have to paint a cynical picture for you, but the reality is that here NASA, in this case, out of the administration work, is proposing canceling a major program in which hundreds of thousands of people, certainly many tens of thousands of people, are not only working, but while the new program, which they're going to recommend, probably has the same number or maybe even a few more because the budget was slightly bigger, nevertheless, there were a bunch of people who were working on the pre-existing program that were going to be fired. Well, people who are going to be fired, you can name, that are going to lose their jobs. And those are votes. And if it's in your district, you can name the people who are going to not vote for you because you voted for the president's program, okay? Whereas even though more people in your district might be hired, you don't know who they are. And they don't know who they are, for that matter. And so you ended up with this weird dynamic where the Obama administration's new program with this Democratic president ended up having as many Democrats opposing it as Republicans. And I'm sitting at one point behind the NASA administrator waiting to testify, and the Democrat chairman of the committee is denying me the right to testify in spite of the fact I had submitted my testimony, et cetera, and had a couple of other astronauts who were testifying against the program, and a Republican member of the committee asking why in the heck this guy who supports the Obama program isn't testifying. I mean, it was crazy stuff. The result of all that, however, was a lot of confusion and a lot of, let me say, lack of coordination in the way in which the new thinking in the program then came about. It is not what one would look at as a coherent NASA program now. Part of the result of that is what Lou said a few moments ago. Many people today think that NASA isn't even doing space research anymore, let alone that there's any human exploration. And so this is a big myth. The space shuttle also terminated, of course, under the Obama administration, but the decision for that had been made ahead. But people don't understand that, and it's not the best time in the U.S. space program, let me put it that way. But there was a real turn in the fundamental thinking about the way we would do space. And in particular, I'll just mention a few of the many changes. First of all, and the most fundamental thing, the ISS, the International Space Station, was up there, and a commitment to continue that work. Technology development, which was one of the quasi-victims in NASA because of the lack of oxygen, everything being sucked out of by the demands of the Constellation program, technology had kind of gone down in the priorities in NASA, and so the new administration recognized if we're going to have a future, you've got to always invest in new technology. And that was one of the major thrusts, and that characterizes what's going on today. But that's not very dramatic in terms of the public. It's not landing on the moon or something. Probably the biggest long-term change was an emphasis on greater initiative being taken by private industry in meeting the new demands of the space program. And Garrett is a great example of that, who's going to be talking a bit later. But there was a fundamental shift which said, let's get the government out of the business of owning and operating and building these things. Let's let the taxi companies develop, and we'll hire the taxi to drive us across the city or up into orbit. And that change is momentous. The rest of the world is, in some sense, still trying to figure out how to adjust to this new American model of private industry taking the initiative on a lot of things. The government's still underwriting, or we're still contracting with them. That's where they're getting most of their money. But the responsibility for it, the initiative, a lot of the risk is now being picked up by and shared by that private initiative. It's basically a new way of contracting, but it's a big, significant long-term change. Now, I'm not going to go into a lot of other things, but that was sort of put out there, that and a few other things were put out there as the new American National Space Program, NASA's new mission. When it came out, there were a number of us who were really, well, one other thing I should mention, and this was embodied in some of this stuff, but pretty deeply, and that is NASA's real interest and the interest in going beyond what we've done was to go beyond low Earth orbit. The sort of, quote, beyond low Earth orbit had been a kind of buzz phrase. But when the program was announced, unfortunately, there was no specific goal on which you could hang your hat. And a number of us were immediately alarmed because without having something and a date by when you were going to do it, where is this program? And so that's when the collapse of the manned program came in. It wasn't at all collapsed, but there wasn't any specific thing you could point to, and that was a big problem. And a number of us beat up on the administration and NASA, and within literally just a couple of months, President Obama took a second shot at announcing the program, went down to the Cape, and identified human exploration of an asteroid as being a step beyond going to the moon, et cetera. This was a new goal. Let's have human exploration of an asteroid by 2025. And that's when this specific identity of a new goal in human space exploration came into being. But unfortunately, that was really a bigger challenge than was anticipated. It turns out now, and I'm going to just skip by an awful lot of stuff, but it turns out now that because of the work done here at the Keck Institute of Space Studies and what you just heard, that we found out that there was a way in which to do this by bringing the mountain to Muhammad, in a sense, because it was easier, we found out with this Keck study, to bring an itty-bitty asteroid back to the astronauts rather than have the astronauts go all the way out to where the asteroids are. And so that, it was, you know, it wasn't anybody's pipe dream even when this was first thought of. But lo and behold, when we looked at it seriously, it turned out that this could be done. And so today, the way in which the astronauts are going to explore an asteroid is to have a small asteroid or a hunk of one brought back into the Earth-Moon system, and then the astronauts going out there. Let me say that the long-term goal of human spaceflight is not really very controversial. Everybody pretty much agrees, timeline forget, but everybody agrees the goal, humans to Mars. The big issue, the controversial part, is how do you get there? What's the logical step? And a number of us believe that the logical step is getting to asteroids with humans and then going on to Mars, not going back to the moon that we did, you know, 50 years ago or something. I mean, I can't stand the image of Neil Armstrong's grandson, or great-grandson even, going back to the moon, you know, as the next American on the moon. I mean, that's ridiculous. So astronauts going out into deep space to asteroids is the new thing. Now, what I want to do before turning it over to Tom and Garrett is to say just a word about deep space. Deep space is not just going a little past the moon. That's not just a little further or something like that. These things are not linear. What you're talking about now is a completely different order of magnitude. In Earth orbit, you're talking 17,000 miles an hour. You're talking a fraction of a second delay time in terms of communication. When you're talking about deep space, you're going around the sun, not around the Earth. You're going at 67,000 miles an hour. You're talking about communication delays of 5 to 17 minutes. So, I mean, it's a completely different world. When you are in, as I was and as all of us were in the past, in Earth orbit, you know, the Earth is always pretty damn big. My buddies went out to the moon. The Earth got a little bit smaller. You could cover it with your thumb, but it was still big and beautiful. Okay, very shortly after you go into deep space, the Earth is nothing but another star out there, and it's a long way off. It's a very different thing. So I tried to figure out how to illustrate this, and this is what I've come up with. On the right, you see a big circle. In the middle of it, that's the sun. This is, to scale, the orbit of the Earth. The sun is about 1 million miles in diameter. The red spot in the middle of the white there. The Earth is so small that it doesn't even show up as a black dot in this big, heavy, thick white line, which I made so you could see where it is. This inside of the white circle there, the inside part is not the Earth, but that's the whole Earth-Moon system. The Earth-Moon system will fit inside the sun without touching the edge of the sun. So it gives you a physical, visceral sense of the difference in scale that we're talking about. More important than that, of course, here I mentioned going around the Earth. You're talking about an hour and a half that you go around the Earth. If you want to come home, it takes you a few hours maybe, or a day or something like that if you want to land in a particular place. If you're in solar orbit, as we're going to be in deep space, going to asteroids or Mars, you're talking about months to years to get back. If you talk about having a toothache or appendicitis or whatever, you got to have the surgeon on board. You got to be the surgeon. you can write some pretty dramatic examples of the difference. If you're talking about the Earth-Moon, now you can do a figure-8 type mission out and around the Earth-Moon system. That might take you 7 days instead of an hour and a half for a characteristic time. But the ratio here of 365 days to go around the sun to an hour and a half around the sun, almost 6,000 to 1. Down here it's 54 to 1. Okay, the distance around the Earth, 25,000 miles. But if you go around the sun, you're talking 584 million miles. So you don't want to think of deep space as just a little beyond the moon. This is a completely different environment that we're talking about. It's a real shift of gears. With that, I'm going to stop my talking. We'll all be up for Q&A afterward, and I'll introduce Tom, and let's see, I think I should be able to do that. With that, Tom, you're on.
Well, thanks. Good evening, everybody. I'm Tom Jones. I want to thank the Keck Institute for Space Studies for bringing us all together to take another look at what we do after the asteroid redirect mission takes place. What can we do with that technology, stretching our capabilities into deep space? I want to thank my colleagues on the study team, and in particular the NASA experts that are here. Our colleagues, some of my friends from Houston, for example, are here helping us out. It just goes to show how much NASA has embraced this new method of getting humans into deep space within the next 10 years. I'm quite excited about that, and really glad that, that NASA is incorporating this into their plans for getting eventually all the way out to Mars. I'm not sure that 3 space flyers are the sole experts you want to talk to when you're considering the future of human spaceflight, but we're all that's available tonight. I'm glad to be with you. My journey into space, Rusty celebrated his 45th flight anniversary. My 20th flight anniversary is tomorrow, and I went above the skies of Los Angeles. Thanks. Went above the skies of Los Angeles to help crew an advanced space radar laboratory that was built at the Jet Propulsion Lab here, along with some Italian and German partners. So we took this radar image of the Los Angeles basin here, and you can see all the great landmarks there that we imaged with the radar camera aboard the Space Shuttle Endeavour. That's me helping operate it and my blast off there. So I'm very grateful and happy to be with my JPL colleagues here this week too. So we'll leave Los Angeles behind and look up in the skies at the International Space Station. As mentioned, this is our human space flight program today. You guys came into the auditorium a little bit too early because at 1 minute before 8, the space station flew over this evening and we missed it. We're all in here. But go out to, on Thursday night at also 7:59 p.m. in the northwestern skies, and you'll see if the skies are clear that the space station is visiting us again. I've got a shot here of the fully assembled space station where 6 people are living. I helped build the space station, so it's really a part of my life, and it's really a stepping stone into our futures in space. Here is Karen Nyberg. Last year she was aboard the space station inside the Destiny laboratory that I helped deliver with my crew to the space station. You can see all the experimental gear in the Destiny. Garrett lived and worked there, and he'll be talking about that, his experiences as an expedition crew member up there. It's the place where we're going to get started studying the technologies to get into deep space, and it's the place where, of course, we're doing fundamental research on the space station to help improve our lives back here, biomedical materials processing, advanced research into chemistry and physics, and so on. The current crew aboard the space station, these are all my colleagues, and some of them are good friends. I've got Rick Mastracchio. I used to work with him in Houston. Steve Swanson as well. Koichi Wakata was a shuttle astronaut with me back in the 90s and in the early 2000s. So some great friends up there along with our Russian partners. And of course, the international flavor of the crew is a distinctive feature of the ISS. And right now, with the shuttle retired, we're relying on the Russians and their Soyuz transports to get to the space station. Now, originally, when, as Rusty alluded to, the plan was to retire the shuttle and have about a 2-year interval before the next transport system came online, the Ares 1 rocket that NASA was developing. We went to the commercial approach, and that's where we are today. The fastest route to get Americans back into space is on commercial transports. I'll mention those in a minute, but we're renting seats on the Russian Soyuz right now. And of course, that's subject to all the ebb and flow of international relations with the Ukraine and Crimea crisis right now. Fortunately, I don't think there's much of a chance that it's going to disturb our relationship with the Russians. I hope not. they've been reliable partners in getting our crew members up to the space station. But it is embarrassing that our country does not have its own means of accessing the space station that we largely built. And I think we need to rapidly move as quickly as possible away from sole Russian monopoly on that access to the station and get our own transports. And here's the three commercial competitors, SpaceX and its Dragon capsule. Garrett's going to talk about that. Boeing's got a capsule concept, and the Sierra Nevada little mini shuttle, the Dream Chaser. One of these NASA will choose in the 2017 timeframe. I think that should be moved up as a national policy, accelerate that date. But that's how we'll get back to the space station under domestic auspices. Now, that'll supply a means of getting the astronauts back to the space station, but we want to go a lot farther, out there beyond the moon and well beyond the moon into deep space, using the ISS as a stepping stone. So NASA's developing the Orion spacecraft to take us, 4 astronauts, into deep space, lunar capable, well beyond the moon, though, all the way out to the asteroids, and eventually it might be part of a Mars crew. The first test flight is in December aboard an unmanned Delta IV rocket down from Cape Canaveral. Where can we go with the Orion? Well, we certainly can go back to the vicinity of the moon. This is an Apollo 16 shot. Why would we want to go revisit the moon, first with robots and maybe eventually with people? It's for resource extraction. The ice at the permanently shadowed craters at the north and south pole of the moon can supply lunar explorers with rocket fuel, with drinking water, breathing oxygen. Maybe it's even going to be plentiful enough to export to use for deep space transportation. So possible resources there on the moon that we can take advantage of robotically. Another place we can find resources is on nearby asteroids. Several million miles away, we'll find a constant stream of water-rich asteroids whizzing by the Earth. The NASA concept worked into the human spaceflight path forward is to go grab a small one in the asteroid redirect mission that we're discussing this week. And so this is about a 7-meter target asteroid that you might snare and then drag back to the Earth-Moon system with this solar-powered spacecraft. Then astronauts in the Orion go out, sample the asteroid that's been encased in this fabric envelope, bring those samples back. You leave instruments behind on the asteroid to not only study the asteroid and its ancient nature and origin, but also start extracting resources like water from the minerals on a well-chosen asteroid. So that's the near-term visit to an asteroid. But we've also got the chance now to take the same technology to visit a captured asteroid just beyond the moon, and then extend that to astronaut voyages to asteroids that might be within a few million miles of Earth, where the voyages might take months, 6 months to a year. And that would be a very important bridge to leave the Earth-Moon system behind, get out to these deep space objects, give us the months-long experience, gives us the operations experience to operate well away from the Earth for months at a time with high reliability, high safety. We're going to need those traits to get all the way out to the Mars system one day. So this is a very promising area, I think, in the late 2020s, early 2030s to bridge our way out to Mars. The other good reason for going to the asteroids, as Lou alluded to, is we've got to learn how to operate around them so that we can nudge a rogue asteroid off course. The Chernobyl event over a year ago reminded us of this constant hazard to the Earth from space. And we can learn, using our space skills and experience, both robotic and human, to nudge off an asteroid from a collision with the Earth. And Rusty and I have been heavily involved in the international decision-making process for protecting the Earth at the United Nations with the Association of Space Explorers over the last half a dozen years or more. Now, if we extend this technology we've had under discussion this week to the Mars distance, Mars comes at its closest about 34, 35 million miles to the Earth. We might think of getting to the Mars system in the early 2020s. This is the closer and larger of the 2 Martian moons, Phobos, in orbit around Mars. And we might think, applying our technology, that we can get there in the early 2030s with human explorers. And from that perch, about 5,000 or 6,000 miles above the Earth, let me go back up, you can perch on Phobos and explore this world. If it's got water on this asteroid-like object, we might extract that for continued use in exploration. And using that propellant from Phobos or Deimos, we might be able to then lower ourselves efficiently down to the surface of Mars in a cheaper and more low-risk way than sending all of these supplies all the way out from Earth for a Mars expedition. So it's very promising to think of our asteroid experience being applied to these Martian moons and then helping us jump the last few thousand miles down to Mars in the late 2030s, perhaps by about 2040. So, can we do this? Technically, I think it's very possible that we can extend our reach to Mars in the next 25 or 30 years. Can we do it fiscally in this country? And this is a matter for our policymakers, the President and the Congress, over the next decades. This is the current federal budget, roughly $3.8 trillion. That little black rectangle up there is the NASA portion of the entire federal budget annually. Only about $18 billion this coming year is the President's proposed budget. I think we're never going to get to the nearby asteroids, let alone Mars, if we don't expand this proportion of the federal budget to a little bit larger proportion than 0.4% of what we spend annually in the federal government. Yes, we're in deep debt, but we also know how to prioritize our spending priorities. Just as an example, a couple of years ago, the stats from the government were that about $65 billion in Medicare fraud allowed that $65 billion to go down the drain every year. So maybe we can siphon off a fraction of that wasted or fraudulent spending and redirect it towards some investment in our technological and economic future, tapping the resources in space and boosting our economy to boot. And in the end, the goal is to, of course, get humans onto the surface of Mars to follow in our robots' footsteps. But that's not the end of the story. Mars has been on our minds for decades. When we get there, we're not going to stop. We're going to use the resources of the asteroids, the resources that we find on the Martian moons, and anywhere else that we can, and use them to catapult our explorers to the frontiers of the solar system and make use of the resources of space to make a thriving economy for our country in the 21st century. So it's all about pioneering, and that means using the resources that are out there, and I think that's where our asteroid redirect mission opens up the potential for freeing us from the resource limitations of Earth. And now over to my friend, Garrett Reisman.
Thank you. So I think I would be remiss if I didn't jump on the bandwagon and say that I am about, thank you, I'm about to celebrate my 6th anniversary of my first flight. Thank you, thank you. So that might lead you to believe that we're going in reverse age order tonight, but that's not true. Actually, we are going in reverse height order. I want to say, first of all, that the analysis and summary of how we got to where we are, the political analysis and the technical analysis that Rusty Schweickart explained to us in his presentation, that was the most astute and concise summary of how we got to where we all are right now that I've heard, and delicate as well. So well done. That was very, very well done. So where we are now, there is, as you mentioned, in my opinion, a very bright and shiny part of where we are right now that is not fully appreciated by the general public, and that is this commercial approach. So what happened was, after my last flight, I came back and I saw what was happening in the private sector. In fact, I was flying a T-38 to do some training at Edwards Air Force Base, and we landed and we got out of the jet, and the Air Force lineman looked up and saw the NASA logo on the tail of our jet, and he said, "Hey, congratulations on that awesome flight of the Dragon today. That was so cool." And I saw his eyes light up, and my first reaction was, well, gee, that was SpaceX. I really didn't have anything to do with that. And then I remember, no, this is a new public-private partnership, and SpaceX never could have done it without NASA's involvement. And at that point, I promptly took all the credit. And I said, thank you very much. I built that Dragon all by myself. Glad you liked it. But I saw something that the excitement in that man's face that day kind of clued me in that something was happening. So I went back, I investigated it, and I did something that's very difficult, which is I voluntarily stopped being an astronaut, that's not something that you do very easily. But I wanted to be a part of this because I saw something very exciting happening. So what's happening is, as Rusty surmised, is NASA's taking a different approach. And there was always private companies involved in NASA's endeavors. Rockwell and companies like Rocketdyne built the Saturn V, the space shuttle. Those were built by companies actually right here in Southern California. And The difference is just the relationship between NASA and these companies. That's what's changing very dramatically right now. And what's happening is NASA is taking less of a direct day-to-day role in the design and development. They're still just as involved as they ever were in certification, which is the phase we're heading into next for the Commercial Crew Program. But what that does is that allows you for those years and getting all the way through the design and development phase, it allows you to progress at much greater decision speed, and that translates to much lower total cost. And the results have been pretty phenomenal with this approach. It started out with cargo, which is what you see here. The Dragon you see right there is our cargo Dragon spacecraft approaching the ISS. That spacecraft was designed and developed, and along with the rocket that carries it, for a total NASA investment of approximately $200 million. Now, in the chart that Tom showed, that wouldn't even show up as a sliver, right? That would be kind of like the diameter of the moon on Rusty's chart of the solar system. So I mean, $200 million sounds like a lot of money. I would love to have $200 million, but that is nothing. And for that money, NASA got a brand new launch vehicle from a blank piece of paper to the first flight. It got a brand new spacecraft also from a blank piece of paper to the first flight. It got a manufacturing facility, it got a test facility, and it got a launch pad and all the operations that go along with doing that for $200 million. Now, SpaceX also put in a lot of money. In fact, SpaceX put in roughly twice that much as an investment. But even if you add up the whole thing for $600 million, that is a bargain. So we've proven that this method really works, and now we're doing it for crew. And I think that that doesn't have to be where it ends. And to me, it's in a very exciting period that we're heading into. It's a golden age of spaceflight, which I think is very much analogous to the golden age in aviation that occurred between the first two world wars. So during that period of time, you had tremendous rapid progress in aviation, but it was all driven by the private sector. Things like Lindbergh's flight across the Atlantic, that wasn't a government program. That aircraft was built by Ryan Aircraft, which was based right here in San Diego. That was a private company. And it was in pursuit of a prize that spurred that flight on. It was the development of the H-1 Racer, the development of the GB, these really incredible machines that really pushed the envelope, but they were all done by the private sector. And so what's kind of remarkable about all that was that you had this massive experimentation and tremendous innovation, because at the time nobody knew what an airplane was supposed to look like. So people were trying biplanes, they're trying monoplanes, they're trying planes with four wings. What is that, a quadruplane? I'm not even sure what that's called. But they were trying all these different designs, pushers and puller props, and it was a great time to be an aeronautical engineer because you could try anything. Now today, you go out to LAX and you look at it on the tarmac, and every airplane pretty much looks like every other airplane. You have to stare at the wingtips to figure out if it's a Boeing or an Airbus, right? Because today we know what an airplane is supposed to look like. Well, guess what? We don't know what a spaceship is supposed to look like. So it's a great time to be an aerospace engineer, because we are experimenting with everything. That's what's so exciting about what's happening. If you look at those vehicles that Tom put on the screen a moment ago, they were all different. Yes, the CST-100 that Boeing is building and the Dragon are somewhat similar in that they're capsules, but Sierra Nevada is building a space plane. We're trying, in our case, liquid propulsion. In the case of some of our competitors, they're trying solid and liquid propulsion and even hybrid propulsion systems. You have all kinds of different competing designs because we don't know yet what a spaceship is supposed to look like. I think it's going to look a lot like that, but but time will tell. So it's a really exciting time, and we're at a cusp of building up a critical mass, but it's also a very, very fragile and critical time, because we're getting successful enough and big enough that this approach is threatening the status quo. And whenever you do that, when you create an existential threat, people do crazy things. And so you see attacks on this approach, and you see it coming in veiled and indirect ways. You see people complaining about the Space Act agreement, the contracting mechanism that was used to do a lot of these programs. And what that is really an attempt to maintain the status quo, which is cost plus contracting, which is what makes a lot of very large aerospace companies very, very wealthy. So we got to keep having success, because the moment there's a failure with this new in this new endeavor, people will come out of the woodwork to point fingers at this approach. It's really, if we get to start flying people into space into low Earth orbit, I think then this approach will be finally past the point of its infancy, and can no longer need to worry about child mortality, if you will. I think we'll get to the point where this will be the clear and obvious solution, and that will be great, because we can do. It would be great if we could increase NASA's budget to greater than 0.5% of the total federal budget. But if we can't, and politically there hasn't been much stomach for that since Apollo. If we can't, we could do more with this less. I was thinking about this when I was looking at your slide, Tom, of the mission to the asteroid, and I thought it would be a terrible shame if we get all the way out there to that asteroid, and we use the same crummy spacesuits that you and I wore to do our EVAs at a shuttle and station. What I'm saying is that there's a role for the private sector to play in exploration. It's not leading the exploration effort. I mean, that is something that is the role of NASA and is the role of government. But along the way, you could leverage the quick decision speed and the efficiency of development in the private sector to build components of your system architecture that would allow you to do more with less. We can make spacesuits that you could use at the asteroid. We're making a spacesuit right now for Dragon, because we looked around at all the existing spacesuits, and they were decades old, the technology. It turns out it's not that hard to make a spacesuit, and we're making ones that are pretty awesome. In fact, the ones we're making, which are just for use in an emergency in the Dragon, in the case of a cabin depress, we're finding that we can make gloves that operate at 5 psi and have much better dexterity and ability to manipulate small things than the Phase 6 gloves we wore when we did our spacewalks. So we're finding that new technology, if it's unleashed, can do all kinds of wonderful things. And if you leverage this commercial approach and have other parts of the architecture built by the private sector, I think we could do a lot more with less. And in fact, one of the criticisms of Constellation was that it was sucking the oxygen out of everything else NASA was trying to do. Orion and SLS are remnants of that constellation, and they're taking up a large chunk of the NASA human spaceflight budget. They're getting multiple billion, I think they're $3-4 billion a year combined, as opposed to we're spending, I think we just got approved for about $650 million for commercial crew. So the criticism that goes along with those large programs is that it doesn't leave money to do anything else. And in fact, even the asteroid mission is endangered as a result, let alone a Mars mission or a lunar mission that would require a rover, would require a habitat. But the thing is, the potential lifeline to these missions is don't develop that habitat or those spacesuits the traditional way. It's going to cost way too much money that you don't have. Leverage this new approach. Let the private sector build the habitat. Let Orion and SLS do the rest of the work. That's one example, but there's lots of potential examples like that where I think we're going to see a hybrid approach. I really hope we see a hybrid approach, private and public, for exploration. And I think if we do that, then we are really on the cusp of achieving some of these great things, going out to the asteroids, to Mars, and I hope not by 2030, because my boss wants to retire on Mars. So if we don't make it sooner than that, I'm going to get fired. So I really hope that that's a very bright and shiny future, that in this period of turmoil that we ended up in, as was described, there can be a very, very positive result. So with that, I'll turn it over to the panel. Thank you.
Please join us on the stage. Well, now we get to the part where we get some discussion going, and if you'd like to turn up the house lights, that'd be great. I can't see. Is anybody out there? But first, let me start out. First of all, if any of you have questions of the other, you get first shot at it. I don't know if you have anything either you want to comment on or say before we get started with the questions. No, we'll get right into it. So I'm up here. I'm going to get the first question in, which is, and then I'm going to turn it over to everyone else. And that is, I really like, of course, I'm very excited about this new asteroid retrieval activity, but I'm really a Mars guy. And I've always wanted to jump to Mars. Why can't we jump to Mars now in the human space program? I think that we agree on the goal. Why can't we do it now?
Crawl before you walk. If you walk first, you're going to fall down. Maybe you survive, but it might make more sense to get some experience in the navigation, communication, radiation environment, etc., in some modestly longer missions of, say, 6 months or thereabouts, by going to an asteroid as a stepping stone before you bite off 2.5 or 3 years on a mission directly to Mars. Plus, I don't think you would get, frankly, the kind of financial support that you'd want without precursors. So, and I think asteroids are going to be fun, by the way.
Okay.
I agree that there can be stops along the way, but I wish we would just put it out there and be very clear about it and say that is our end goal. And just whatever we do between now and then is fine. We did lots of things before we went to the moon. We did lots of things on low Earth orbit as stepping stones. But you're absolutely right that the lack of a clear and compelling destination is really hamstringing not only our political situation with getting political support in Congress for the space program, but in capturing the imagination of the American public. And if we just put it out there as like, Mars is the destination. We're going to do a couple stops along the way, but it's all about Mars. It's all about getting to Mars. I think that would change a lot.
I'd just add that given the chemical propellants that we use in our rocket engines now, it's going to take about 1,000 tons or more of chemical propellants in the spaceship to shoot astronauts to Mars. And we simply don't have a way to get all of that mass up. Maybe the big rockets that you guys are building will help us do that. But we might take our time extending our reach out into Mars, even as we develop the ability to use propellants that are found in space, water from the asteroids, water from the moon perhaps. Use those propellants in space, lower the launch requirements, make the cost more affordable and more palatable, and then work our way out asteroids, the Mars moons, and then down to Mars itself. That gives us a chance to have our technology catch up with our ambitions over the next 10 to 20 years.
So let me invite those who have questions, first of all, to be brief, but also to line up at microphones, which are on both sides of the auditorium, or I guess right here and here. And I'll be calling on you. I'll also be calling on or reading some questions that we've gotten from online participants. This is being webcast, so we'll be doing that. I do want to note that you made a good point here in the history, which is, we didn't jump to the moon either. There was the whole Mercury program, there was the whole Gemini program, and a number of Apollo flights before we got to the moon. So the idea of jumping with just the first, and that was the moon goal, and I think most of us would agree the Mars goal, even today, is much harder than that goal was back then. So
More
it's,
unknowns, right?
More unknowns, and so, are there any questions here? Yes, please.
They're first.
I'm sorry. Okay, first, yes.
You mentioned the moon, and I'm one of the people who is curious why we set foot on it and basically never went back, because my understanding half a century ago was the goal was to have permanent bases on the moon. And for some reason that I don't understand, the moon has become uninteresting.
So, question about the moon, and
He's the Apollo guy.
The problem with all that is that the Apollo guy can't hear as well as anybody else. So I kind of missed the.
He wants to know why we stopped and why we didn't continue going back to the moon.
Why we didn't continue going back to the moon?
Why not? Yeah.
That's a fascinating question. I'm not going to give you a good answer, but let me say that I visited the Soviet program just about the time when it was transitioning from Soviet to Russian, and I still remember my first direct hands-on experience of the Soyuz back in those days. That was in the, I guess it was in the early 80s. And I learned really rapidly when I saw the Russian program at that time for the first time that the Russians, who were not capitalists, of course, had no idea once they got something working how to stop it. And what they went into was infinite production. You never do anything different. You do it the same way again and again and again and again, meeting quotas. The United States, on the other hand, who are capitalists, once you do something 2 or 3 times, for God's sake, stop and do something totally new so that you hire a whole bunch more engineers to do the next thing. I mean, it's very interesting. So the argument at the time that Apollo was actually terminated was not, do we go on to Apollo 20, which we had planned, instead of just to Apollo 17, but should we stop at Apollo 15 or 16? I mean, it was the pressure was amazing to witness firsthand at that time. But the argument was really, let's stop. And the reason to stop was not just because everybody wanted to get on to a new thing, but also think of the price if the next one we do, we have an accident. Why did you do it, for the 5th time when it's risk but not much gain? So it was a very interesting time to be in the middle of that program and see that decision. Not a satisfactory answer, but an answer, The admission was right?
Okay, next question here.
So this is a question for SpaceX. I think it's great and it's very exciting to see the privatization model moving forward, but there's one thing that makes me nervous. Do you have more than one customer?
Do we have more than one customer? Yeah, so the answer is yes. But we're not counting on that for our business case. So we're at the stage now where that private market for human spaceflight is still relatively is very difficult to define. It's very difficult to quantify. It's clearly out there because every time Space Adventures has offered up a Soyuz for sale, a seat on one of the Soyuz to go to the ISS, somebody's bought it. So there clearly is a market. How big is that market? How much money is in that market is difficult to tell. But you do have the promise of a lot of additional revenues. And what you see companies like Bigelow Aerospace that are developing destinations. Because we could sell, the nice thing about this commercial approach is that the companies own the intellectual property. So if we want to, once we're up and running and we're providing services to NASA, we could crank out another Falcon 9, another Dragon, and use it for whatever we want, short of giving it to North Korea. Not anything we want, but we wouldn't want to do that anyway. But anyway, I don't know why I brought that up. But the point is that it enables us to do private low Earth orbit missions, maybe even private cislunar missions. We can do stuff like that, and so we're going to see what that market is. But an astute businessman would probably not put down a lot of their own money as investment purely to chase that market because it's difficult to know if you'll get an ROI. So we hope that it's there, but we really need NASA to be the anchor tenant, and that's what NASA is doing. But the nice thing is that once we accomplish it, and if we could continue to bring the price point down by achieving affordable reusability, which is another thing my company is working on, that opens up all new possibilities for not only for private space travel, but also for new unmanned missions or manned missions as well. If it costs a lot less to get a pound of payload into space, it will just generate all kinds of possibilities. Sorry for the long-winded answer.
All right, thanks.
Okay. Next question here.
Now as things are going and as the installations get larger and more people will be up there for longer periods of time and more satellites and more rockets go up and have jet stages jettisoned, is there a plan to deal with debris? I mean, to deal with it in a long-term situation, because the hazards are going to grow probably exponentially as more and more stuff gets up there, and it could be pretty catastrophic. So is there a plan long-term to deal with those?
Back when I was on the NASA Advisory Council, we had a good look at the space debris problem. And so you remember a few years ago, the Chinese wiped out one of their own satellites for an anti-satellite missile test. And that doubled the collision risk with the International Space Station because the debris was filtering down to where the ISS level was. I hope you weren't there at the time. So that long-lived cloud of debris just from that one satellite being shattered is going to hang around for 10 to 20 years. That debris tends to be very long-lived, and of course, it can generate multiple collisions down the road that then create more debris. So the facts are that today, even with responsible spacefaring countries agreeing to decommission their satellites by deorbiting them or sending them into a high safe orbit, the fact is that the debris hazard is going to continue to mount over the next 20 to 25 years before it starts to slowly decline with atmospheric drag cleaning things up. And the space station is designed with debris shields to sustain hits from small pieces of debris, because we know that it's a risky environment up there. So to remove the debris is quite expensive, using most of the conventional methods that have been suggested. The only one I've heard that I think might really have some promise is to use a large, a laser or directed energy device on the ground to ablate and thus deorbit space debris above you, but that looks just like a weapon system when you build one of those things. And so other countries may not allow you or may not encourage you to do that deployment. And it's a problem that we're going to face internationally, I hope.
And think about it, without space debris, you wouldn't have had Sandra Bullock panting in space.
Yeah.
I was going to ask if the movie Gravity had made you more sensitive to this topic.
Actually, it's great being at Caltech because it's the one place we can go and not get the question, how realistic was the movie Gravity?
And the first question online is, how realistic was the movie? Oh, no, wait a minute. Let's skip that. No, the first online question is, do the recent discoveries that humans are full of bacteria essential to human life complicate spaceflight? Would we contaminate any place we visit?
Yes.
There's some NASA people in the audience who have a much better grip on this than I think we do, but we've got to find a compromise between keeping our dirty selves from contaminating the sterile, pristine Martian surface and finding out whether there's anything living beneath the Martian surface. So we have to find a way to smartly do that, but then eventually we want to colonize Mars and other celestial bodies where humans are going to be allowed to spread their bacterial cargo everywhere they go. That's a fact of exploration. So unless you do it strictly with robots, which I think means you're never going to find out the fundamental answers to questions about life on Mars, for example, then we're going to have to accept perhaps some human contamination and then keep some other national parks on Mars free from that.
The world is tough. It'll adapt.
And Tom's point is absolutely essential to understand that we have to do it because you can't prove a negative in science, so you're never going to prove that there is not life on Mars. But, so you will have to come to grips with that question as you explore there. Okay, next question over here.
Hi. I'd like to poke at the Phobos possibility because it seems that combines many of the advantages of the asteroid and a direct destination of Mars. Because, first of all, Phobos is big. It's 10 miles across, weighs 10 trillion tons, I think. It has some gravity so that you don't have things drifting off like you do with an asteroid. And it's likely to have different, like it has poles that would possibly have more water and other areas that wouldn't, and it should have some material from Mars to give us a taste of stuff on Mars. And it's also a destination on the way to Mars. It's clearly a stepping stone to Mars. And so I wonder if you could comment on the possible obstacles. Obviously, the distance and the time is an issue, but we're exploring that already with the space station. We're putting people up for 6 months, and we're talking about putting them up for a year. Does it seem reasonable to establish a base camp on Phobos for the exploration of Mars, where we could stockpile stuff and investigate making propellant for vehicles that land on Mars and so forth.
It was in your slide.
Tom, in tennis, we call that a lob shot for you.
Okay. Well, first of all, turn right around and talk to Brian Wilcox right there, who's a great Phobos expert, and he has a lot of great technology ideas about how to use Phobos as a literal stepping stone down to the surface of Mars. So just a short answer to your question, I think you're right in the way you stated the assets that Phobos brings to it. We need to find out very quickly whether there's actually water in the minerals on Phobos or on Deimos, the more distant moon of Mars, because then we can extract that and use it for propellant to getting ourselves down to the surface. That's a fundamental thing we should do right away with the very tight NASA budget. I hope we can pry out a little bit of money for a robot probe to the Martian moons to find out their composition very quickly. And then the other thing I would say is that it does not only put you physically close to Mars, in that, you know, we have the appeal then of Mars filling a quarter of the sky overhead, and that'll draw us humans, us curious humans, down to the surface of Mars as quickly as we can get there, I think. But we also have the ability to use the nice dynamics of Mars and Phobos to make it more technically easy to get down to the surface. Instead of coming in from an interplanetary entry trajectory with a big heat shield and having to slow down from interplanetary velocities, if you can drop from Phobos down to the surface, you have an easier entry environment, and you might be able to get a bigger payload more readily down to the surface of Mars. And then I'll turn it over to Brian after the meeting.
And by the way, it is on most people's roadmap to people on Mars.
Okay,
So.
good, thank you.
Next question from online doesn't actually specify that it's about human spaceflight, and I'll let the panelists comment if they think it is, but we are in Pasadena and near JPL, and so we have to ask this question. Are there any plans to collect samples from the geysers of Europa or Enceladus? Anybody?
Just from what I understand, NASA's now studying a Europa mission, and one of the easiest things you could do is if you can get into an orbit around Jupiter, you can skim through the plumes coming out of Europa and then collect and measure that.
Enceladus.
Oh, you were talking about Enceladus.
Well, that's where the plumes are.
Yeah,
Oh,
no,
both
also
places.
Europa now.
Both places.
Oh, Europa too?
What you want to do is skim through those plumes with a mass spectrometer and measure the organic content, if any, of that water plume to see if that might be evidence of biological organic activity down there.
Yeah, they've made new discoveries about Europa, and they've also made new discoveries about Enceladus having an underground or under ice sea. So it's these are interesting places. They're probably not human destinations in the timescales we're talking here, but the idea of collecting samples from their geysers is certainly going to receive some study. But there are no plans to do it, is the immediate answer to that. Okay, next question here.
I've heard of a what do you call it? A probe that went out into deep space that had an ion engine. Was there any thought of implementing them to get to Mars or any other planets?
The Deep Space One tested ion engines, and they've been used in many applications by many nations, as a matter of fact, already. And we've got
Dawn spacecraft.
Dawn going out right now, which it's been out there, for 3 years, continuously thrusting, I think, or something like that. So they're very interesting engines, very efficient. They eat up a lot of electricity as they get bigger and bigger, but they're very efficient in terms of using fuels. And they're very interesting for almost all of the work that we're doing in terms of the long-term exploration. And the mission that we've been talking about, the asteroid retrieval mission, counts on the use of electric propulsion in order to be able to bring an asteroid, collect an asteroid, and bring it back. So yeah, that's the future of high efficiency propulsion in space.
At least to be carrying the heavy masses. They're great for as cargo vehicles and carrying an asteroid, and it enables the asteroid mission and everything like that. They're not fast, but they really do carry heavy masses. Okay, the next question online is, what do you think of applying biosphere technology to setting up a colony on either the moon or Mars?
Well, I was on the advisory committee for the Space Biosphere project in Arizona back many, many years ago. We learned a bit about that. It was not a great success, but the concept of a biosphere is still a very interesting thing. And of course, Gerard O'Neill developed the whole concept back in the 70s of a space biosphere and space colonies floating through space. Closed environmental cycles are obviously a very interesting subject. We don't really know how to close an environment all the way, but even doing it part way, generally speaking, saves a lot of something, time, money, that sort of thing. So this is a technology which will get more and more, will become more and more expert in as we go along and as the continuing pressure to save money grows. And of course, I think all of us who've flown in space, and especially the Russians, really were pleased when they first started growing seeds in space and seeing little green things come up. I mean, everybody wanted to tend the garden and rub the plants, you know. So it's a very natural thing for humans. That's not true when it comes to recycling waste materials like your own urine, but, you know, these guys have done that too.
Actually, no, I haven't. When we went up, the wastewater recycling that we have on the ISS was in place on my last mission, but as a shuttle crew member, I got to drink the nice, fresh fuel cell byproduct. Yeah, and those poor guys that were on the ISS had to essentially drink the processed byproduct of the rest of us visitors.
They're going to bottle it, by the way, and bring it back.
Yeah. So it is, though, an illustration of really the value of the ISS and what it offers as a test bed. And I think that's the strongest contribution, other than actually the political aspect of the ISS program. We haven't fully closed the system, but we're getting close on ISS. We've done some experiments where we've grown plants that could be the precursors to a hydroponic food supply, growing your own food along the way. You can't, when you go to Mars and you look at these missions, you can't pack all the Cliff Bars you would need to feed yourself for all those years. It's just mass prohibitive. So looking at ways to grow your food along the way is very promising. We're experimenting with that. But as far as the water cycle goes, we have come a long way. And as we're joking about it, they do currently on ISS collect all the condensate through air-liquid heat exchangers or condensing heat exchangers. They collect the condensate. They collect, and they also collect all the urine, all the wastewater as well. So we're able to recycle that now on ISS, and that was a difficult thing to do because the chemical process is not so straightforward, and the plumbing is not so straightforward, especially in zero-G. But we've got that working now after some fits and starts, and we're able to collect most of the water that we expend on ISS. So we hope that we continue to get smarter about that because it's absolutely a technology we're going to need.
Yeah, the first veggies are undoubtedly going to be broccoli and Brussels sprouts.
No doubt.
Go figure.
Okay, we only have time for one more question. I take it over this way. Someone there?
Yeah. Yes, the young lady.
Okay, please.
After the mission to Mars, are you guys thinking of maybe visiting another planet or their moons?
So, what's next after Mars? I have an opinion, but I'm
we
not
might all
on
have
the
our
panel.
personal favorites, right? What's yours?
I don't have one.
So, Mars is about 1.5 times farther from the sun than the Earth is. It's the closest we can get to it is about 35 million miles. Beyond that, Jupiter is the next planet out, and there's a big asteroid belt, big empty space with a lot of rock debris in there. So Jupiter's 5 times as far from the sun as the Earth is. So it's a big leap for even our Mars technology to stretch out to the outer solar system. Venus is too hot to land on the surface, and Mercury's, an airless, also very hot body. So going in closer to the sun doesn't interest me too much either. But I think hopscotching our way out through the big asteroid belt, where there's lots of water to use for rocket fuel and for drinking water, might be an efficient way to get eventually human explorers out to some of the moons of Jupiter or Saturn to get to the bottom of what's at the bottom of those oceans on Enceladus and Europa.
Yeah, I think if you look at the total land area of asteroids, because they're small and there's so many of them, millions of them, hundreds of millions of them, you've got a tremendous area there, and and they have a lot of interesting minerals and things because they're primordial materials. So I think the asteroid belt forms a tremendous total surface territory to explore. The idea of the early pioneers in the United States, or the 49ers, coming here to California and exploring for gold, et cetera, that kind of mapping and exploration of the area, I think the asteroid belt provides an almost endless turf out there to really explore and understand. There's a lot to learn about it. There's a lot of good stuff that you can mine and process. And in the process, we can also help protect the Earth from the occasional devastating impact, which Tom and I have been working on for years. So,
And,
you took all the...
Right, yeah, our time is up. I just want to add, in response to your question there, it's not just about getting to Mars. There's going to be a lot to do on Mars. Mars is going to occupy us for hundreds and hundreds of years as humans try to adapt to that planet and use there. And so I think it's not just getting to Mars, but it's what we do there. Yes, I am a Mars. It's being there as a multi-planet species. And with that optimistic note, which I think we are optimistic about the future of human spaceflight, and I hope that you all feel a sense of optimism with not just the great ideas, but people really doing something about it. People not just up here, but in the audience, many of the participants in the program. We're going to get, and of course, a new generation who's going to make it all happen. So thank you very much.
Thank you.